question?
Yeah. So I just want to clarify. I think I missed some point in your presentation. So in your presentation, basically presentation, you have configuration which look like more like a star configuration. Is it necessary that you should have a common node in your configuration, that node C, which is going to connect every other node? Is that a requirement, or it will work for any architecture which forms your configuration?
Yes. For the algorithmic part, we only consider the static network is a star, because we believe for the higher layers it can be abstracted as a packet switch. That's why we are specifically focused on one layer's links. That's why it's abstracted as a star.
Okay, great. Thank you.
But of course we prove that if even it's like a tree have a height 2, it's already NP hard. But if it's star, it can be solved in polynomial time. And our next work is give approximation based on the general graph.
Okay.
Thank you.
Okay. Other questions?
Ricardo, can I make a question? I was
Absolutely.
raising my hand, but I'm not sure about the protocol here.
Absolutely. Go on.
Thank you, Ricardo. So thanks for the presentation. I was wondering, from your results, it seems like that the approach that you label like SM, so I think it's splittable non-segregation stuff. It's more time consuming than the other version. Significantly, I would say. The other version is what you call the US, I guess. But what about, say, the performance? Is it actually going better, or significantly better, or say it's equivalent?
Okay, this is a very good question. Yes, indeed, what you say is true. We have considered 4 different routing models. Some of them much easier. It's like segregate on the unsplittable. But in general, what we give the routing time, it's for all this routing model. What's a difference? Because as you remember, we have to do this optimize the routing for this each triangle. For this to compute this local triangle, the same different routing give a different running time. And on the other hand, because you just have a routing for each triangle, we have to merge them together. When you merge them, different routing will cause different running time. But in general, by our method, if you just suppose like a decision problem, suppose you have a threshold, then you select a matching, you always have to suffer that running time. That's it. Thank you.
Oh, okay. Okay, thank you. Can I just take the opportunity to make another question, Ricardo, or are we?
Of course.
Okay. We have been working for quite some time about consolidation inside the data centers in the perspective of energy efficiency. So I was wondering, in this hybrid architecture, do you think it is possible, I don't know, to think about some form of consolidation that maybe takes advantage of this, hybrid architecture? So it's a more general question because it's a curiosity I had while you were giving your presentation. When we are working about consolidation, the idea is that you would do something that's somehow at the opposite of what you are doing. Instead of, say, spread the load around, you would try to consolidate the load on a few servers to save some energy by putting in sleep mode other servers. And that, well, in energy efficiency is a quite popular, methodology for reducing consumption. So I was curious if maybe the hybrid architecture of data centers could be used in this perspective, if you have this in mind. Otherwise, just a curiosity.
For your reminder, yeah, we have to consider this power efficiency aspect. We almost focus on how to minimize this max load. So, but what you said seems quite interesting and possible working directions.
Okay, yeah, because maybe the hybrid, maybe combining with an approach like yours in a subset of the servers, for example, I don't know. But anyway, thanks a lot. It was just a curiosity. Thank you.
Yes, but I read some other papers. It seems the circuit switch have a much less power consumption than this packet switch. That's why I guess if we redirect more flows on this circuit switch, perhaps it's more power efficiency. But I don't know. I just know roughly
Okay.
circuit switch should have a better power efficiency than this.
Yeah, I
switch.
guess so. Yeah.
Thank you.
Yeah, thank you.
Okay. Any other question? Well, actually, I too have a curiosity, and I was wondering if having some kind of knowledge about the presence, for example, in a data center of virtual network, not VLAN. I mean, groups of virtual machines that are likely to interact among themselves. Can this a priori knowledge be used together with the VM placement scheme to somehow reduce the number of configuration that you have to evaluate? So can it be used to speed up the convergence of your algorithm?
So as far as I understand you, you mean maybe our demands, this pattern are a little special. We already know that. Then if our algorithm can be speed up, definitely I think it can be speed up. For example, what we kind of consider if all these demands is the same, it's either 0 or 1. It's like this kind of matrix. It seems because we prove the problem quite hard, but under this situation, it seems it's much easier to solve than general way. And for your question, I think if it shows some pattern, maybe we can have a subgraph induced by that pattern. They're more focused on solving the subgraph, but something out of a subgraph, we don't need to consider. That's why for this kind of a reconfigurable link, so we can just cut off without any concern. So I definitely think it would be helpful if you know some special structures of your demand metrics. Thank you.
You're welcome. Okay, are there additional questions for this paper? If not, then maybe we can switch to